Second. Okay. Screen. Welcome, everyone. Good afternoon. Welcome to the FLOATFARM Women4Wind webinar. We'll start in a few minutes, waiting for a bit more participants to join, and then we'll kick things off. Thank you very much. Emmanuel, can you just confirm that everything is recording?
Yeah, I think everything is good.
Perfect. Okay, let's wait 1 minute and then we'll start. Thank you for waiting. Okay, I think we can start our webinar. So good afternoon, everyone. I hope you're all doing well today, and I'd like to extend a warm welcome to our webinar. My name is Ines Martorell, and I'll be your moderator for this event. We have an exciting and informative session that is planned for you, and I'm here to ensure that everything runs smoothly. Before I present the agenda, I'd like to go over a few housekeeping items. If you encounter any technical issues, please use the Q&A feature or the chat feature, and we'll try to assist you. And we, of course, encourage active participation. So if you have any questions during the webinar, please use the Q&A feature, and there will be a time dedicated to answering through all your questions. This webinar is being recorded, and the recording will be made available on the FLOATFARM YouTube channel and as well as the FLOATFARM website. Our agenda today will take us from the why to the how, and on how of advancing gender balance in the wind sector. We'll begin with a keynote on why this subject matters, and then we'll move into the presentation of the FLOATFARM project itself. After that, we'll hear stories from women entrepreneurs and researchers who are driving change on the ground. And we'll then open up a short panel discussion on a core question that is, how can we ensure the gender dimension is meaningfully integrated into EU collaborations? And we'll finish up with a Q&A session and, of course, wrap up and conclusion. To kick things off, I'm delighted to introduce our first speaker for the keynote, Virginie Robin. Virginie is the founder and president of Euronovia and recognized expert in EU funding and EU research and innovation project. After roles at the CNRS and the French Ministry of Higher Education and Research, she launched Euronovia in 2014. She now leads a company with a team of more than 10 people, 10 consultants, securing Horizon Europe, LIFE, her Erasmus Plus Interreg project for high impact initiatives. She's a founding member and vice president of the EAIC, and she's a mentor to women-led startups. She turns funding into innovation with measurable impact. Thank you, Virginie, for being here. The floor is yours.
Thank you, Ines. So I'm very happy to be here to introduce this webinar and why this subject matters. As you said, I'm the CEO of Euronovia, which is a company I founded 11 years ago with the ambition to make EU projects more impactful and more inclusive. So if we start the presentation, I wanted to take a look at the current reality and the numbers in the wind energy sector And we have a report from the International Renewable Energy Agency, IRENA. And when we look at the numbers, well, they date from 2020. Only 21% of the global wind energy workforce is women. Less than 8% are in technical and engineering roles, with even fewer women in senior leadership or board level positions. I haven't found any more recent numbers, but as more recent data shows, the wind energy is lagging behind in the average workforce for renewables. There are some improvements, but the wind energy is still behind. There is an increase, but it's still low in the wind energy sector. So there is a gender gap clearly here, and it is a missed opportunity. Next slide, please. So there are barriers to break. Why aren't there more women? So this is more globally. In the EU, there is a gender bias in STEM education and recruitment. There are workplace cultures that are not inclusive or not supportive for women. There is a lack of visibility and role models for women generally, and specifically in the wind energy sector. And there are gaps in mentorship, promotion, and policy. If we look more specifically in the wind energy section, this is what we found. There is a technical and engineering bias, especially in university and technical training. Some on-site and fieldwork requirements are outdated or not adapted to women. There is still a male-dominated workplace culture. This is also true in the wind energy sector, unfortunately. There are limited gender policies and data available. As we've seen, we don't have any data except dating from 2020. And there are still educational and recruitment gaps. So why inclusion matters? This is a topic which is very important. We've seen, and there are lots of reports, and we have seen now, including more women is better innovation, stronger business performance, and also addressing the talent shortage. This is true in every sector, and it is true in the wind energy sector also. So, as a conclusion, what can we do? The wind energy sector has an enormous potential worldwide and the EU, not just for decarbonization and economic value, but it can also set new standards in inclusive development. If we bring more women, we multiply our strength, and EU projects are a great opportunity to make a change, since the EU has policies and is pushing towards more women, for instance, in EU projects. So thank you all. Thank you to the speakers and the organizers to be part in this movement. And let's make things work to have a stronger, fairer, and more innovative world in the wind energy sector than ever. Thank you.
Thank you, Virginie, for your insightful presentation. We'll now move to the next item on the agenda, which is the presentation of the FLOATFARM project by its coordinator, Joseph Savrin. Before we start, I'd like to present Joseph. Joseph is so as I said, the project coordinator of the FLOATFARM project. He's a postdoctoral research in the field of mechanical engineering at the Technical University of Berlin. He attained a dual bachelor's degree in math and mechanical engineering at the University of Queensland in Brisbane, Australia. And then he completed his master's in mechanical engineering at the Berlin University of Applied Science. He attained he became a doctor in engineering and in mechanical engineering, to be precise, at the Technical University of Berlin. Since then, he has actively carrying out research on numerical modeling of aerodynamics and hydrodynamics problems in the domain of wind energy, and his focus is on fast numerical modeling of wind turbine wake dynamics and platform hydrodynamics. Thank you, Joseph, for being here. The floor is yours.
Yeah, good afternoon, everybody. Thanks, first of all, go to our presenters for taking part in our webinar today, but also for everybody who's attending. I'm going to give a brief overview of the FLOATFARM project. If you could go to the next slide, please, Ines. So I coordinate FLOATFARM. I was part of also the preparation of the application. And I think giving you a brief overview of the FLOATFARM project might give you a nice introduction to kind of what we'll talk about today, wind energy, and also the other partners, the clustering partners who are going to be involved. So to give you a bit of background about where the FLOATFARM project came from, it was built as a follow-on project from Flowtech, which was a Horizon 2020 project, which was funded between 2020 and 2023. So 2020 and 2023. And we developed a lot of numerical technologies and control methodologies in Flowtech, and we've basically extended that in FLOATFARM to look at critical technologies for floating offshore wind. So the floating offshore wind farm of the future, not only looking at singular technologies, but also now specific technologies which are devoted to interaction between turbines, whether it be mechanical or hydrodynamic, aerodynamic. The main goal is to contribute to decreasing negative environmental impacts, public acceptability of float farms, but of course also the standard objectives of reducing LCOE and increasing uptake of floating offshore wind energy. Slide, please. Give you a few details about some background details of the project. It has a 4-year runtime, started at the beginning of last year and will end at the end of 27. We received 6 million in funding. You can have some information there about the project call, what sort of action it is. It's a research and innovation action. And finally, we have quite a large and diverse consortium of 17 partners in 8 countries. So we're spread all across Europe, which I'm really happy about. It's a fantastic feature of the FLOATFARM project is that we include a lot of different groups, whether they're from academia or industry. So maybe you could go to the next slide, please, Ines. So we have quite a nice spread of both industry and academic partners. I believe we have seven academic partners and 9 industrial partners. So a very good spread. All of the technologies that we're developing, there's oversight from industrial partners. It's not just purely academic research. But in both industrial and academic sides, we have key expertise in a lot of different areas, not only in manufacturing and installation, but also the modeling side, numerical and system optimization. So that's a big part of the FLOATFARM project is optimization. So physical and engineering sciences, we have quite a lot of engineers and physicists active on the project. A new part of FLOATFARM is a focus on biological, environmental, and social sciences. So we're not only looking at the, in inverted commas, classical engineering topics, but also looking at environmental impact, looking at marine noise, what impact does this have on the marine ecosystem, and also the social science. So it's the sociological side of it is how do we impact uptake of floating offshore wind energy? How do we take steps towards educating the community about floating offshore wind in the hopes of demonstrating to the general public the potential of this technology. So I think that's the next slide. Okay, of course, I missed that part. There's also a pursuant to the previous point about reducing the LCOE, all of the optimizations and technology development that we're doing in the project. We'll always have an eye on economy and cost modeling. So there's a full work package devoted to that so that any technology we investigate or introduce is also seen through the scope of is this economically feasible. So slide, please, Ines. There's a number of objectives of the project. I'll go through them directly. Lower LCOE, that was what I mentioned before. Moving on to objective 2. Fort marine component design through multi-scale demonstration. So part of this is demonstrating at a range of scales the technologies which we're introducing. So we're doing not only numerical experiments, but also experiments in laboratory setups and in real world scenarios. So we'll be doing experiments in the Port of Naples, experiments in wave tanks, and also numerical investigations. So objective 3 is looking at sort of interaction between turbines in terms of aerodynamic interaction. So this is looking again at farm sort of applications. How can we control turbines in a floating offshore farm so that aerodynamic interaction is reduced? Again, with turbine interaction with objective 4, we're looking at shared mooring. So if we actually mechanically connect the turbines, how can we reduce materials, for example, reduce material use, and through that get reductions in LCOE. And finally, last but not least, the fifth objective, which is to reduce environmental impact. So I can't stress enough that that's a really important point. And I think we might go into this topic a little bit later about this particular objective and work package. That this is a really important point in floating offshore wind. It's okay, Ines, you can stay on that slide. That there's a lot of unanswered questions about environmental impact of floating offshore wind, because it's still a relatively unexplored technology. So we're trying to answer some of these questions. So both the academic and the industrial and the public have a good overview of what the impacts are. I'll give you a bit more of a sort of a graphical overview of the project here, is that it's broken down into 3 actions and a cross-cutting action. The first action is turbine level technology. So technologies devoted to technologies which are applied to a single turbine in isolation. Action 2 is technologies which address multiple turbines. This is relevant to objectives 3 and 4, which I named previously. The third action is environmental and socioeconomic. So how do we loop these in under, what are the environmental impacts? What's the economic impacts? And finally, sort of a glue action, so to speak, or a glue work package is MDAO optimization. So when we introduce any of these technologies, how do I optimize the full system so that we get, for example, a minimum interaction with the environment, or a minimum cost of energy, for example. So there's no point in isolated optimization of these systems. We need to do sort of a full global optimization, and that's what the cross-cutting action is devoted towards. Slide, please, Ines. Yeah, the last slide is on clustering events. So in the scheme of what we're going to be talking about today, inclusivity and bringing different groups together, trying to heighten collaboration, trying to maximize collaboration and bring different groups, social groups, and also academic and industrial groups together. We have 4 projects which were funded, three other projects which were funded together with FLOATFARM, the same call. I'm happy to say we have representatives of all of these projects here today. The Infinity Project, Made4Wind, and Tailwind. We'll be discussing in the open round a little bit later. And the role of these clustering activities, of which this webinar today is one, is to enhance collaboration, facilitate exchange, and also at the end of the day really move towards increasing policy impact and advocacy. Okay, so that's relevant not only to the technologies in here, but also our topic for today is striving towards more equality in the wind energy industry. Okay, so that's just a quick overview. I'm not sure if I've gone over time, but yeah, thanks very much, Ines, and I'll pass the floor back to the next presenter.
Thank you, Joe. So we'll move now to the next item of the agenda, and we'll hear stories from women entrepreneurs and researchers that are driving change on the ground. Before we start, I'd like to present our first speaker for this agenda item, and it's Lieselot Ulfgaard. She's the CEO of Agnesia Wind AB and CDO of Agnesia AB, and where she leads research and development and commercialization of a novel low-speed generator, that reduces raw material use by up to 90% and increases efficiency, enabling lighter, more sustainable wind turbines. With a PhD in ocean energy, she previously worked at DNV on grid code compliance across Europe. I will now give you the floor, Lieselot. Thank you for being here.
Thank you so much, and thank you for inviting me to this. So I will say a bit about my journey, how I got here and what I do. It's honestly the first time I do such a speech or talk. And initially I was a bit not uncomfortable, but it's a bit new to me, like trying to present your own journey as if it was an intended path that you're on, because honestly it hasn't been. It's just, in retrospect it can look like that, but in the end you just jump between things and you end up somewhere, which is sort of part of the journey, I guess. And regarding the fact, how the fact that I'm female and how that all has fitted in, hasn't been a huge aspect from my perspective as I see it, which is perhaps as it should be. So I've been quite fortunate in that regard. But it will be really interesting to hear everyone's stories and journeys. So starting from the end, as I was introduced, I am the CEO of a company called Women4Wind, which is part of this of the FLOATFARM project, developing a novel type of wind power generators. I will come back to that. I'm also the CTO of the mother company, which is just Hagnesia. Since Hagnesia.Wind focus on wind turbines, Hagnesia focus on also other applications, because a generator can also be a motor and so on. I will come back to that as well. But regarding my titles, sounds of course super fancy, being both CEO and CTO of such a novel deep tech company. To that I can just comment that that's one of the perks of working in a small startup. Then you get the opportunity to get the fancy hat and the fancy title, simply because there's no money to recruit an expensive one. So I think I have a super interesting role, and I'm still trying to get a grip about it, and I'm growing with this role, and I guess my plan is to try to keep it as long as I can, to be honest. But starting from the beginning, I'm Swedish. I currently live and also grew up on one of those two islands in the Baltic Sea, the one that's actually named Island Land. But I moved around a bit. I did my master's and PhD and everything in Uppsala University, a bit north of Stockholm, which I did in engineering science, ocean energy. It was never really the plan that I should do a PhD. I was never, I had a route, but then one day I bumped into the professor of that department that worked with really cool stuff. And they just found money for this big research project in ocean energy and in wave power technology. So I sort of jumped at this and ended up spending 5 years in that, some research and some teaching, which was not at all what I intended or what I thought it would be, as I think a lot of PhD students can attest to. It was very hands-on, very engineering, very little academic, very little research. So in the end, I would perhaps not merit my academic part so much of this, but I learned a lot about how to lead myself, how to be resilient, and how to be a good engineer. So I'm very grateful for that opportunity. That being said, after I finished with that, I was more than done with academia. So as some do after doing a PhD, I sort of felt a need to leave and go into industry instead. So I sort of jumped at a job posting in DNV, who is a big consultancy firm doing a lot in certification and such. So I moved to Hamburg and started working with the DNV, which was quite a cultural change, I would say, going from sort of this Swedish flat informal work culture, basically no organization at all when it comes to these academic groups, into working in one of these old German companies that works with standards and certification, which is very, very much by the book. That was quite a contrast, but also very rewarding. I love that part, working abroad, getting to know this different work culture, and I was very well taken care of with my colleagues. So I was on a kind of good route there. I really liked working with DNV, but then once in a while I had this old roommate from university used to call and talked about his innovation, his grand plan of how to build some electromagnetic magic machine who could improve motors and generators. And one day they actually hadn't worked with him a lot before, we were just roommates, but somehow I managed to make an impression. So when he and a co-founder of his managed to land some research funding to actually start building a prototype for this, they asked if I wanted to jump along. So I did. So I think 3-4 years ago, I joined Hagnesia and was supposed to work with certification and this part, which I haven't done so much. I've been doing this and that. Now ending up doing a lot of project management, working with our strategy, applying for research funding, being part of a project like this, which is so much fun. So looking back, jumping this, you could look back at it and see that it's been some sort of red thread with renewable power and wind power and generation, but it's been a lot of just jumping opportunities and seeing what I like and what I don't like, and taking it as it comes. So that's a bit about my background. I want to say a few things about what it is that we do at Hagnesia. So what we do is to build wind power generators, at least in Hagnesia Wind. If we step back and look what Hagnesia does, it's basically to develop and commercialize a novel type of electrical machine. A generator and a motor is basically the same thing in this regard. One produces power, one produces mechanical force. And the innovation we build this on is electromagnetic design, which is really, really good at slow speed application. Basically, normal generators and motors are really, really good at high-speed applications, but they're really crappy at low-speed applications, which is why you typically have a gearbox in your car or in your machines or in your wind turbine. And as you can imagine, wind turbines are extreme in this regard because they move really, really slow, like 10, 20, 25 RPMs. But we have a technology that actually likes to work at these speeds and actually becomes both more efficient and also very material efficient. When we talk about wind turbines, we can build generators that are 90% smaller, lighter, using 90% less magnets, while still having a higher efficiency. So this has so much potential. And I would say that wind power is really our strongest case. It's not the simplest products because they're very, very big and we have a really, really long way to go. We are currently at TRL4 and we are 12 people. So we are still in the building test bench models, building it just a bit bigger every time and trying to validate it for different technologies. And this is where FLOATFARM comes in. The FLOATFARM is basically for us a project where we can get in touch with wind power engineers and researchers and get the help from them to understand what sort of impact can we have, how should we design this generator so that we actually get as much impact as possible on the floating wind turbine. Does it matter how much it weighs? Does it matter what inertia we have? Which is super good feedback for us design-wise, and will also help us to push our technology forward so that we can get new projects and that we can find investors to actually see the value in this. Because it's not only the generator that becomes cheaper and smaller, it's the whole wind turbine. And so far we get really promising and good results for floating wind power. So we are getting super appreciated. It was such a good project for us, getting this feedback and be able to understand how this all fits together inside a wind turbine. Currently we are spinning along with this. We are now applying for an IEC transition project, which is sort of also a big research project, which FLOATFARM is helping us to qualify for. So let's see. I hope that we will see something more regarding that. So that's sort of in FLOATFARM. I'm sort of the interface between the FLOATFARM community and my company, where I have all the engineers that does the design, that does everything. And I think that says a lot about my role in general in Hagnesia. I have a PhD, I'm super technical, I'm an engineer, but I still, in the company I work with, I'm more of the generalist. I'm the one who's able to communicate really deep technological, but can still explain to other people's roughly what is it what to do and where do we want to go and what sort of work do we need to do. And if we sort of try to wrap it up and regarding sort of lessons learned regarding my journey, I think that's sort of the key. I'm still I've jumped around a lot, done a lot of different things. And I think one of the reasons why I've done that is because I'm still not really sure what my thing is. I've never been like, I want to do exactly that, or I want to be that sort of expert. I'm the generalist, and I'm starting to realize that that's what I like to be. I love to work with really, really technical people. I really like working with researcher and working internationally. But me, myself, I'm a generalist and finding my role in this. And when giving advice for how to, for the future, I would say we should really encourage people to take chances, to try out different roles and to try out different types of companies, because beyond the work that you do and the tasks that you have, I think there's a lot of different cultures in different kind of roles and in different kind of companies. And that's really important, how you like it in the culture. There's a completely different culture if you work in research in academia, or if you work in a consultancy company, or if you work in a small startup. And to me, that's been very helpful to understand how these differs and what I like and what I don't like and what fits with me. So my advice in general is to just jump in, try out things, try different things, and try to help each other to find those opportunities to try different things. So that was what I wanted to share. And I'm not sure how well I stayed with the time, but feel free to ask questions if you have any. or to reach out outside of this call, of course.
Thank you very
Thanks.
much, Lisa, for sharing your story. It was really interesting to hear about your journey. We'll now move on to the next speaker, which is Cristina Madrid Lopez. Cristina is a Ramón y Cajal researcher at CIEMAT with an interdisciplinary profile. She evaluates the social environmental impacts of energy transition, policies and technologies using mixed methods that blend qualitative social analysis with energy and environmental modeling. She has led and coordinated more than 10 projects, Horizon Europe, CIST ERA, and authored more than 50 publications in 40 high-impact journals. And she's active in science communication and citizen science, and she serves on the board of the International Society for Industrial Ecology. Cristina, welcome, and thank you for being here today. The floor is yours, and to change slides, don't hesitate to tell me.
Thank you, Ines. Thank you, everyone, for being here today and for the invitation. It seems that we are on fashion now, no, to explain our lives, and sometimes I heard people saying that this is irrelevant or that this is like a token. I think it's still necessary, unfortunately necessary, that we speak up, that we say what we've done, what we have been going through in a good way, not only in a bad way. And I wanted to share with you or to emphasize the imperfectness of my journey. No, it seems that to become a leader, you have to do everything right from the beginning, and you have to finish your degree and then do a master and then a PhD, or that might not always be the case, and that's fine too. And that gives you a baggage that it's important and is relevant for the future, and it turns you into a kinder type of leader, I guess. So here is more or less my career. Started, as you can see, 20 years ago now, when I was a PhD student. I actually did not get a grant right away, so I worked as a research assistant for some time until I got actually a PhD grant. And then because the challenge I wanted to take up over during my PhD was too big, I actually did not finish within the 4 years of the grant, my PhD. I finished 4 years later in 2014. But during that time, I got also the experience and the publications needed to win a Marie Curie grant, which is a kind of a very prestigious grant that took me to Yale University. So what in principle seemed to be something very bad, that is delaying my PhD, actually turned out into an opportunity to win a better grant, no? And then arrive to this university. After that, I was working as a postdoc. I had the opportunity to not only work in a few more projects, but also lead them, then become a director of research, like a PI, as we call it in academia. And then lead a team of 12 people. We have peaked actually at 17 people, which is quite a lot. And then I won, last year I won a fellowship that actually will ensure that I will get a permanent position at the university, because even though in research, because as a research director, I didn't even have a permanent position. No? So you can, Ines, if you can click again. Here is a like very summarized idea of what I've been doing. I actually started my research as a person who studied irrigation and agriculture and water issues. But that actually, I realized that water was not enough and that energy is what moved the world. And then I went to study shale gas and fracking, trying to connect both. And in that impasse, when I came back from Yale University, I actually worked in a project called Sentinel, when I discovered energy modeling and Python programming. And then I thought, this is what I want. I am an environmental scientist by background, so and from a generation where programming was not part of the university degree. So coming back to doing modeling and learning how to do R or Python was kind of a challenge, no? But then it feels that it was what I wanted, and I did never have the courage as a PhD to say no, I want to do modeling, and I want to do modeling with Python or R, no? So there is a lesson to be learned. As you can see at the top, There are two icons. If you click again, Ines, you will see how these icons have affected my citations, which is something very important in research. Here is when I had my two daughters. I had one of them in the US, the other one I had them back in Spain. And I think the image speaks for itself, so I'm not going to say any more about it. But indeed, motherhood is a challenge, especially when you are in academia and if you want to lead research. Could you go to the next, please? Then Ines asked us, what challenges did you have? So I have highlighted two. Challenges in academia, like in any other career, are many. But maybe I will highlight this one, to be a postdoc and being a mom. Postdoc is a time when most of us women in academia are in the time to having kids, because it's the usual time in life. But then it's also a time when you are supposed to be publishing like hell, as they say, because it's when you have to establish. So it's very difficult to combine having young children, and the best way you can cope with that is actually to have the appropriate partner for that, and the support of family usually, And every now and then, why not a guilt remover? So when you are traveling abroad and you see your children, they are very small, if you come back with the occasional piece of chocolate and share it with them with a smile in their faces, and you sit with them, they tell you what you have done, and then you share the chocolate together, that's also fine. And then maybe the other challenge that I can share is to be at the same time a leader, but then not having a permanent position, because permanent positions in academia are achieved through publications mostly and project acquisition. However, you, as a PI, you don't publish yourself so much, because in my opinion, if you do it well, you actually are there to support others to learn. So how are you going to publish your research if at the same time you are leading a team with 15 people and paying attention to them? If you can do both, is that maybe you are not doing them well, no? So that was difficult, and indeed the support in here was the mentors that you may have in academia, asking them how they did it, like good mentors, like people with content, not with posturing. And then the colleagues and the team, and choosing the team wisely, and actually being truthful and empathic to them, and letting them know that you are imperfect and that you need help sometimes as well. No? So this is another way of doing leadership. Next, please. The one thing that made a difference. So life is never, like there is never like just one turning point. There are many turning points in life. But I think the one thing that helped me is to realize I have my own mind, and that I had the right to, like I want to do modeling, for example, no? And be brave. And be brave also as a person who does holistic assessments, no? Actually, I am the person leading the holistic assessment of a wind project, and that's how I arrived here. In a world where most of the people is thinking in economic terms or in technical terms, no, and also where social and environmental aspects are not always the most relevant ones. So I think speaking up, having your own mind, and being brave enough, and being kind when you share with others usually works. I think the next one is the last one, maybe. No. So yeah, so I have a homework for everyone. So I wanted to encourage you to try tomorrow, not tomorrow because it's a Saturday, so maybe you have the weekend, no? On Monday. So just consider over the weekend this thing that you have inside that you have not, oh, thank you for the heart. This thing that you haven't tell a colleague or an employee or a student of yours or your boss, something that you actually don't like and that is making you feel unhappy as you work. And then maybe telling them, just try to make it respectfully and being empathic on why this person may be doing this thing that you don't like. Maybe they don't have a choice, I don't know, but maybe trying to speak up for that. And here is my homework to you, something that has worked for me and for my students in the past. So I think the next one is indeed the last one. So the message is, leaders don't need to be perfect. We are people. We are imperfect. We hesitate, and you don't always have. So people have to perceive you as a good place to come for support. But knowing that you may also need support, and that's fine. No? So I think if we are brave and kind enough to recognize that, we should be okay. So this is what I had to share with you. And of course, like my colleague before, if you want to reach out, feel free. And I didn't tell you a lot about my actual research because I think you can always look for that on Scopus and find out.
Thank you very much, Christina, for sharing your story, your tips, your insight based on your experience and your life. We'll now move to the next speaker that will share her story in the industry, which is Beatriz Mendez Lopez, and she's a senior researcher at CENER since 2011. She specializes in wind turbine aerodynamics and computational fluid dynamics. She holds an engineering degree, a master's, and a PhD in CFD, and completed a Fulbright postdoc at UC San Diego. She spent 9 years in this industry, like at Airbus or Acciona. I'm not going to cite all the companies she worked at, but she worked in a lot of different companies before. And at CENER, she has contributed to major projects on airfoil, blade design, surface roughness effects, rotor CFD, and offshore hydrodynamics. And now she coordinates the Horizon Europe Air project. But I'm going to stop sharing my screen, and she'll be sharing her screen for the rest of her presentation. Beatriz, the floor is yours.
Okay, thank you. I guess that you can see my slides now. So thank you very much first to FLOATFARM, to Joe, and also thanks to the audience and the previous speakers. The presentations are very, very nice. So it's true that it's a challenge to make this presentation because we are used to make technical presentations all the time. And when they ask you, can you make a presentation of your journey with energy and so on, it's a challenge. So I'll try to do my best. I'm going to start with a picture. This is a picture that was taken in 2003. So it was 22 years ago. This is me 22 years ago. And it was a project that was called Sirocco. It was a FP5 project. I was working at that time in Gamesa Eólica because I started the other way around. So I started working in industry and then moved partly to the research in universities and then to a technological center at CENERIS. So at that time, we started to work in understanding the noise that wind turbines produce. So wind turbines at that age, days were 58 meters rotor, and they seem very, very big. Now these wind turbines are really small, but at that time they were very big. And we were working here in setting up this experimental campaign. It was an experimental campaign with noise measurements. You can see here in this picture with the wind turbine as the track. Is the same track that we have behind in this picture. And this is something that I did at the beginning, working on a company. And it has been very relevant. I go to conferences, to technical conferences on wind energy, and I can see this picture because it was, I think, the first time we made measurements trying to understand how noise was produced by wind turbines. And sometimes that you identify that is just a project, at the end it becomes something very relevant. After that, I have been working in as I said, in the industry and then moved to CENER in many aspects, mainly in aerodynamics, airfoils and wind tunnel experiments, rotors and so on, and simulations in many projects, and also in some things that are really innovative. You can see here this video of a project that finished last year that is called X-Rotor, in which we work on designing these different approaches or innovative wind turbine rotors. This was a technology readiness level very, very low. So for me, the challenge in this case was, as Christina said, to balance professional and family life. I have 3 kids. So during these years, I work on this research and also on the family aspects. And I would like also to mention that these topics that we started many years ago are still relevant. because wind turbines are becoming bigger and bigger, and the research that we did, for instance, in noise, in blade erosion, and so on, again, a challenge when you move to offshore, to big wind turbines, to floating wind, and so on. And I would like also to highlight this picture that I have here of the InWind project. It's a project that was that ran between 2015 and 2018, something like that. And just a funny note, you can see here that there is a group of 26 people, and you can only see 3 women there. I'm the one with the white trousers. So after this aerodynamics research that I did in many fields, then we found a new challenge that is floating wind energy. This is a challenge that is shared with FLOATFARM project. And even though I had the keys, I had all this background behind me, it is always the opportunity to find, or there is always the opportunity to find new challenges. All of you know that floating wind energy is a real challenge. It's a complicated problem in which you simulate the aerodynamics of the floating platform, but also you include the rotor. So in CENER, we have been working on many things on that regard. So this is one of the big challenges also that we face in our careers, the technological challenges. And last but not least, one of the challenges that I'm facing now is to coordinate an European project. This is the project that is called AIRE. And that is a challenge because you have a big family of people working with you, and you also have the European Commission, and you have to make it work during 4 years. So this is a challenge. This video is what we study in AIRE project, is to understand how climatic conditions affect wind energy. This is a wind farm that is close to CENER. It's our experimental wind farm, and the wind turbines are there. So sometimes wind turbines operate in conditions very challenging. I add here some information about the project that is not very relevant for this workshop, but what I would like to show you is that this is the last meeting that we had in AIRE project. So in our project, you have 4 women that are work package leaders out of 7 work package leaders. In this picture, we are 11 women out of 22 people, so 23. So I think the picture has changed compared to the previous one that I shared with you, and we are very proud. I don't know how we did it, but I think we are very proud of now in wind energy and in the technological parts, we can see more and more participation of the women. So for driving the change, I will say that collaboration and diversity are essential. Education is a key challenge. I don't have to mention it. I would like also to say that in the past, we always worked to make wind energy more efficient, but now in 2025, we need to make wind energy more efficient, but also more reliable and more respectful with the environment. So this is a challenge. And for the next generation, I would like to say that contribution to the development of clean energy is always very rewarding. And I add the last picture of my talk. This is my little daughter. And we have gone to the school explaining what is wind energy several times. But this class, they were 5 years old at that time, and they made their own wind farm and with recycled materials. And from their own innovation, they decided to make all of them colorful. So this is the rainbow wind farm. So it's also a very good part of our job, that you can go to kids and explain what wind energy is, and they see this very nice picture. So thank you very much.
Thank you very much, Beatrice, for your presentation. It was really interesting, and the last picture is really joyful. So thank you very much.